So this is the day for our final oral presentation. All right, we finished the final exam, and I think that's nice. You have the score for the final exam, and also TA that you have the answering sheets, graded answering sheets. So right now, let us have the final oral presentation. So you see, we have oral presentation and final report. All right, so these are two different items. So later, you need to let me know your members. For example, group 3, we have members here. And step 2, you have the PPT slides. And of course, you need to have some possible demo. And possibly, I may ask you to change your code. If today you cannot finish that one, I mean, currently you cannot finish that one, then you need to let me have the results after the class. All right, so right now, I will try from group 3, 4, 5, 6, and later get back to group 2 or the other groups. So right now, group 2, ready? 6 minutes first. Group 2. Oh, sorry, group 3. This one. Your members and the presenter. And of course, I will follow the evaluation form on the syllabus. So, sure, you should take care all of the possible factors into the consideration. All right, so first one, 6 minutes first. Okay, go.
Hello everyone, we are group 2. Today we are going to present group 3, sorry. Group 3, we are going to present our final report. The TCP socket trading system. Here is the list of our group members. Let's get started. Here is the overview for the presentation. First, we'll start with the introduction to explain why we pick these topics. Then we'll jump into the features to show you how our system can do. Also, we prepare the features to the demo to show you the system in action. We will also show the problems we run into and the solutions we come up with. Next, we will have a short discussion about the architecture. Finally, we will show you the conclusion and job distribution. Now, let's start with the introduction.
Okay, here is introduction, and why we choose this topic as our project topic is because trust server use a TCP protocol to handle messages from clients, and it also fulfills the requirements of the project. Saki programming and the difficulty of implementing a trust server will be either too easy or too hard. And it's very suitable for collaborative work. So based on the above reasons, we choose to implement a trust system as our topic.
Here's our 5 main features of our project. First is base function, which allows users to enter their nicknames and start chatting. Account system allows users to register and logins. Start chatting after users log in their account. Comment system allows users to type comments to get information online. Users or send private message to specific user. File transfer allows users to transfer pictures or other files. And front-end provide an easy-to-use interface for users.
Okay, so for the programming testing part, there will be a demo video will be presented to showcase a basic chat function or an accounting system, as we mentioned, and also common function and file transfer capabilities.
There are some problems that we deal with. One of them is when a user closes the terminal directly, not a normal exit, an index error happens and the chat rule cannot work properly. And our solution is we use the built-in exception handling in the Saki library to detect when a client disconnects. When this happens, the server removes the user and notifies all other users immediately. And another one is after adding send and download command, the user can use send command to send a file. But when other user or sender itself try to use download command to download a file, it will disconnect from the chat. And our solution is at the server side, we use to byte function to transmit the size of the message to a client in order to indicate the certain size of message is coming. And client side, we use from bytes to get the size of message from the server. Then it can get the information properly.
And another problem we made is initially we store usernames and passwords directly in a database. But since this project was locally deployed, so anyone who can access the database could view all users' accounts and passwords. And yeah, so this is not very safe. But actually, even if the database were not local, storing password in plain text is highly insecure and should be avoided. So the solution is before we storing password in the database, we encrypt them by using SHA-256 to ensure that even if someone accesses the database, the actual password are not exposed.
So, time's up. Daddy have 1 minute, 1 more minute to finish it.
So this is our login interface, then we will try to register our account in here. So we check the username and password here. Then we enter the chat UI, and I will try to log in again with wrong account. So if we try to log in with the normal account in here, we will try to type the message and to see that if another user has received the message. Then here, I will use the command to try to view that another member is online too. Yes, in here I parent message another member. Then yeah, he received it too. In here I will try to private message myself. Then Yeah, the server will not let that happen. In here, I upload my data to server, and this is successful. If I try to upload with same data, they will duplicate it and notify me. In here, I try to download the data, and that the server notify we download successfully. In here, I demo the download the content. Yeah, so I log out the system and log in again. All this history has been saved. This is our demo video.
So that's all right? Okay, thank you.
Presentation, thank you very much.
So before go forward, wait a moment. Let me adjust something. Here, right?
Yes.
Same 6 minutes. Okay, go.
So, use the mic. Sorry, wait a moment. Okay. So, hello everyone. We are group 4, and yeah, our topic, we choose the real-time sensor simulation data streaming using UDP. Yeah, so simply speaking, our project is about to complete a multi-sensor IoT data collection system using UDP sockets. So it's like a multi-client to server architecture. And I will pass the stage to Brandon.
I'm not quite good at controlling the slide, so we can just browse it. Okay, and this is just for the introduction. So we use just JSON for the message formats, and this is also an application layer protocol. And for the just that you know, we try to add multiple field data instead of just plain text in our project. Okay, so. And also for the reference, we use JSON for the benefits, including the human readable and compact format, such as this kind of characteristics. And for the UDP, just like you know, UDP is connectionless, as mentioned in the class, right? So it's good for the multi-sensor concurrency, okay? And also it has no guarantees, so it could be simple, fast, immediate, which suits our project's goals very well, okay? And for the, but just like you know that sometimes the security is also, sometimes the security and stability is also very important. So we add some optional application layer with a reliability mechanism, such as the app and sequence numbers in our formats. Okay, just like the picture shown on the right-hand side. Okay, and also for your reference, we mentioned IoT, so I just put the definition of IoT on the slide for your reference. And just like you know, our project aims at constructing a simple, actually it's quite, of course it's very simple in the class, okay, and so it's based on UDP. Okay, so now let's get to see some overview of our project. For the UDP server, just like what I mentioned, we use JSON message to make the information human readable, and also the field will include the temperature, humidity, just like usually you will see in IoT in your daily life. And optionally returns act. This can be set by humans. And okay, so other things are being the same with our UDP in the class. Okay, so now for the screenshots. Just like you know, we use JSON, and it is included in the Python, so it's very easy to write, easy to code. Okay, and also just like what I mentioned, the ACK is there, and the information will be encoded in UTF-8, so you can read it very directly without being how to say that? Being confused. Okay, and then about the client side, actually in the real world IoT, of course, the data is not rendered, but for the project, for the goal of the project, we just use the random temperature and humidity values. So it is still encoding in JSON. After arriving at the server side, will be decoded to the UTF-8, and just like what I mentioned, reliable mode. Okay, so now let's see. Okay, so as you can see, we have a reliable part, right? So this is a if. So you can choose whether to conduct such function or just use a very simple and fast UDP function without any guarantees of security and bandwidth. Okay, so if not, you will just break this part. Okay, this is just for your reference. Okay, so now this is for the operation because I think we have sufficient time to maybe we have sufficient time, but we are not sure whether we have sufficient time to demonstrate a demo. Okay, so we just give you some screenshots. Okay, as you know, this in this case we use two sensors. You will see two sensors, right? Let me check. Oh, you got room 1 and office 1. Yeah, so there are two sensors and two fields now. So you got temperature and humidity. Of course, in the reality, you can add much more fields to make it more real. Yeah, okay, and we use reliable mode because you can see that there is X, right? I forgot to put the white block there, but you can see there is an X. Okay, so you can check whether the message has been delivered successfully to the server or not. Okay, and for the so it seems very easy, but we have some conclusions and suggestions, and also how we solve the problems we encounter. Okay, as you know, with the characteristics, why we choose UDP instead of TCP, just like what is covered in the class. UDP is very good for the fast and simple application, and if there is no congestion and flow control, of course, sometimes you might encounter some situations that we need some kinds of security guarantee. So we add it on our application layer. Okay, and with JSON, as I mentioned, it's human readable. As you know, you can see the temperature and humidity directly. Okay, and then there are flexible fields, right? So you can add a lot more fields into the projects. Okay, and it's compact format. Actually, it can to say more detailedly, it can make the project use less bandwidth, and in the real world, of course, the IoT needs a lot of data as more than here. Okay, so
1 more minute.
Okay, this is the last page. So this is just for the if we want to extend the project, maybe we can make the format more organized. For example, like you now see, of course, it's just like a text, right? So you can transform it into something like a table or something else. Okay, and any other computations that are useful, you can also apply it. Yeah, so integrated different functions into it. So for example, like you can convert it into a panel database and conduct some statistics and then convert it to, or even to use it to call other loops. So any functions can be added into the project. Yeah, that's all for our presentation.
Do we have like 30 seconds, sir? Or not? Just because of the demo video, but
you can show us the demo video for a bit.
Okay. Actually, most of the part have been covered in the slides. Yeah. Okay, 30 seconds. Oh, you cannot be full screen. Is that okay? Okay, so.
So it says it works, right?
Yes.
Yeah, it works, and you will see. You can add more servers, more client, of course.
All right, so that's all. And then we have one question. And you have 2 sensors, right?
Yes,
and
or more.
1 server.
Yes.
So actually, they are different, but you said the IP to localhost. So how you have the scenario to cover a server, maybe a server maybe far from the 2 sensors? Have you ever tried?
We haven't tried that.
So you just try the nearby sensors.
Sorry?
And how you have the sensor? You still use the process to denote you have the sensor there? I mean, how you have the sensor?
You mean how to connect them?
You still use a computer to serve the sensor?
Yeah, here in this
In
part.
this project, yeah.
Okay,
Like
okay.
random
All right.
yeah.
No? That's okay, no problem.
Thank you.
Okay, thank you. And next one, 3, 4, and 5. Maybe I jump to 6. All right, maybe later get back to 5. And before we continue, I've seen 2 members for good 4. And how about the other members? Okay, the role actually just allow you to have the full points. So as for the others, you need to let me know your status. And good 6. Maybe you can demo directly to me, to the camera.
Okay.
Okay.
That would be nice.
Yeah, so yeah, you can use mouse and you can use your fingers.
Touch screen.
Yeah, touch screen.
It's very fancy. Okay, our project is about a online multiplayer games, and this is our project overview. You can just see it. The system architecture is actually we have several modes on this game, but today is about online games, so we only talk about connection games. Okay. Next, and this is the all system overview schematics. Next part. Well, the most important part is the Saki part. So we talk about the Saki how we implement it, and we do it in cross-platform type. We target 2 architecture, Windows and Linux, but sometimes the integer part is a little bit hassle because you're using Linux. You know that integers are different sizes when it's using Windows. So this part we'll talk about later because this is the problem we encounter, and we usually using C++. So sometimes we can use macro to avoid it. That to target what architecture we are using. We're using TCP to connecting with clients and hosts because we need to maintain the connections between in the games, so we don't lose the connection using UDP that we didn't send, and the receiver didn't receive the game data. You can see that we're using our game is reversal, so we just recorded a 8x8 board status to transit it to the other players and receive it and check it if other player is valid to place that pieces, and he can continue again. Next slide. This is our overview to send the data, and we're just using row by row to send the data out of the board. And every board can have every cell that we send it can have 3 status: blue, not blue, black, white, and dot. Dot means that you didn't place any pieces yet. And we're using 32-byte integer to avoid it that different platforms have different type of integers sizes. And we just transmit it, and we can check all receive that we abstract the TCP part to let us know that we did actually transmit every single data out, and the transmitter can know that okay, we are fine. We are fine. This week have nothing major failures happen. And next part. And this is our server part oversight of how the playing schematic goes that every how the things how the program flow is going. Export, and this is the part that we have slightly issues that different architecture have different TC sockets need to be implemented at different kind of macros that they use in differently. So it's kind of hard to implement all of this on just one particular function. We need to use macro because we could not use other things on C++. So this is the server side. What we do, we just call that we just bind the port to 53,000 and just listen the connection is okay, and let the client send the things that he can receive stuff, and the client side will connect to the IPs by string format. So we can just probably see how it goes when we are demoing the actual program. This is the part we counter because the same function have the different implementation between different architectures. So the problem is that we need to have different functions to implement in different architectures that we separated, and we abstracted into a single function that we can use across the platform. So we can reuse these servers components in a later project or other things that people need to use.
You can speak louder.
Windows subsystem for Linux. So because we backend is using OpenGL, so it's cross-platforming. So we don't need to care about the rendering API stuff, and we can just input the host IP addresses to the client, and it will connect and open to Windows, and we can just play it or destroy.
So you have 2 players, right?
Yeah.
And what's the default IP?
No, we don't have default IP. We just check the current hosting IP. And we just
hosting IP. Yeah, that's true. You will have the hosting IP, and you will join one later, right?
Yeah, join later when the host is open to connect.
Okay. All right, that's it. Thank you.
We didn't use server, so we using PTC.
Okay, I see.
Do we need this one?
Yeah, finish.
Okay.
Yeah, I asked you the question, so finish. Thank you.
Thank you.
So next group, go to ready. Go to. Okay, here. So. Jiang, you should remove your group.
Hello everyone, this is the group 2 final presentation. Our topic is multiplayer puzzle game. About a reverse game rule. You can see your final report on Padlet. Now I will pass quickly. Upon launching the program, the menu will show the three options: PvP mode, AI mode, and quick button. If you click the PvP mode, it will show the game mode screen, and it consists of the three functions: local game, host game, and join game. Also has that button. The game option allow user to play with friends using a single computer. The host game option open connect port, allowing other players to connect to your computer for remote game. The join game option allow user enter host IP to join host game. The AI mode enable the user to play against a computer control opponent. This mode is designed to help players familiarize themselves with the game rule and mechanic before competing against real people. This photo was taken while using two computers connect via a local network. This demonstrates the game networking capability, which allows two players to compete from different locations over the internet.
We use SFML network module, and it relies on TCP. And the picture shows that the package structure we designed. And this is our connection logic. And if we choose host mode, the host mode will be the server, and will generate a port that we can connect. And this the time mode. Just type in the host size generate IP, and we can join the game. These are some details of our game loop. We use non-blocking I/O for better experience. And that's it.
We also have a demo video to show.
Okay or not okay?
This is our final presentation. Thank you.
Okay, thank you. So we have a group 2, 3, 4, 5, 6. Oh, sorry, 5. Group 5. Three members, right?
Yes.
Here and here, fingers as well.
everyone, welcome to my presentation. My name is Xipin. Our group is Group 5. And today I will present my project, Network Tic-Tac-Toe. And we took a simple game and made it into a multiplayer game using a network. Here is the outline. I will talk about our goals and key concept and how the server works. Okay, our main goal was to build a stable network game, and we use a client-server model. The server controls the game state. The client shows the game to the player. And there's three key concepts: TCP, threading, and locks. First, we use TCP because it is reliable. We must make sure every move is correct. And second, we use threading to handle two players at the same time. Third, we use locks. This stops two players from changing the board at the same exact time. And now let's look at the server code. To make the server safe, we set a timeout on the socket. This helps the server shut down clearly when we want to stop it. And this is how we handle game moves. When a player makes a move, we use a lock. This makes sure only one person updates the board at a time. It keeps the data safe. After a move, the server tells both clients to update their screen, and then tells the next player it is their turn.
Okay, now let's look at the client slide. The key idea here is the UI must stay responsive. We use two threads. The main thread runs the TK inter GUI, and the background thread listens for late message from the server. When data arrives, the background thread uses TK inter's after function method to pass update back to the main thread. This prevents the UI from freezing while waiting for network data. When a player makes a move, the client immediately sends the move command, updates its own board, and disable inputs. This gives instant feedback to the player and makes the game feel more responsive. The client is responsible for handling server commands and updating the UI. We use a dictionary to manage marker colors so the board stays visually consistent. All server messages are handled in one function. For example, turn enables input. Seek move updates the opponent's move. Win, lose, or tie ends the game and shows the results. Opponent disconnected shows an error and exits it cleanly. This centralized design keeps the client logic simple and clear. To summarize, this project combines multi-threading TCP sockets and game logic to build a responsive multiplayer application. For future work, there are three improvements: stricter synchronization between client and server, using JSON instead of plain strings for communication, improving scalability with asynchronous I/O like ASIC I/O. Thank you for listening.
So I think you can start the demonstration. All right, so.
Or I can use my phone because we can.
Sure, demo here. So you can say something, how it works.
You just start a server Python.
Oh.
And the client Python program, and you can have two components because here is the course and this is the circle.
Okay, I see. Thank you. That's all. And finally, it's a good one. Five members, right? Okay, go. Your mouse and your fingers.
How do I present?
Okay, go.
How do I present? Okay. Yes, welcome to our presentation. Our topic is SMTP-based socket programming, implementation, email communication simulation system. So let's jump to why this project matters. So modern applications require secure real-time communication between multiple users. Our project goes beyond basic client-server examples by implementing multi-threaded concurrent client handling, end-to-end message encryption, private and public chat rooms, robust error management, and this addresses real-world need for secure messaging platforms in enterprise and consumer application. So the points that we wanted to focus on is multi-threaded server, which is we do by implementing a fully functional SMTP server capable of handling multiple concurrent client connections, an asynchronous processing by designing and implement a message queuing system for asynchronous email processing and delivery, and secure access by incorporating SMTP authentication mechanism to simulate secure email transmission using the plain method. So our technical goals for this project was to modular architecture with clear separation between client and server components, comprehensive error handling for network timeouts and disconnections, and threading or async for concurrent operations.
Okay, thank you, Fanya. Now let's continue to the next part, and I'm gonna go through this very quickly because it's better to show than to say. So there are three parts here in the system architecture overview, as you can see: the client, server, and data storage. And the main technologies that we use are these with PY, and that's the project structure. Okay, next. And the next part is the multi-threaded SMTP server, which are divided into 3 sections, which is the main server lump, the client handler threads, as well as the state machine implementation. In this project, we weren't able to completely focus on our goals as we have it all on our report, but we will show a sufficient demo next. Alright, okay, so now it's the message queue and client application design. This is two categories into 4 sections, and let's just move on to the next part.
Okay, so on the server side, basically for the socket implementation details, it creates a TCP socket bound to a specified port. Then we bind it into a port and then keep it in a listening loop to accept connections. Each new client, then it's handled by its own thread, so multiple users can send messages at the same time without blocking. On the client side, however, we connect using the socket API and then run a simple dual model setup. One thread listens and then receives the messages continuously, while another one handles user input and sends messages. The snippet shows the receive loop. It reads the data, broadcasts it, and on errors and empty reads, it triggers like the cleanup. Yeah, so I also explained it here. So then on the advanced features slide, we also added the ESMTP, like functionality, the size limits, message size, outplane, adds authentication, then the pipelining improves the performing, and also the 8-bit TMIE supports the richer message content. So then finally, we also added the detailed logging for traceability and rate limiting to reduce abuse and simulate real server protection.
Okay, so the demonstration scenario, I think I will introduce you this just at the end of the presentation, so you can next pass the slides. And technical challenge and solutions. We implement many technical solutions for the SMTP server. And first of all, as we can say just before, thread synchronization issues. A thread is like a subnet in the network. It can create an independent running program that didn't block the main program, so it's very important. It can allow several clients to connect to one server. We also implement unexpected client disconnect. If a client disconnects of the server, we have to take that and stop the connection in the server. And we also implement a mailbox and a queuing that I will introduce you just after. And future enhancements, we can implement a JW2 based authentication system and a new interface, I think.
Okay, so right now let's talk about the team contribution and collaboration. So there were different roles concerning SMTP server core implementation, client application developer, authentication engineer, message queue specialist, and storage system developer, and for finishing, testing, and documentation lead. So we have a repartition like that. And we use during this project different kind of tools. Concerning version control, we used a GitHub repository. Concerning communication, we used a Line group for daily stand-ups and code discussions. And for the documentation, we use Google Docs. So let's make a short conclusion about this project. So it permits to get key learnings like authentication mechanics and secure access. Also, this project enhances our understanding and of how fundamental internet operate. So yeah. So thank you for listening to us.
Your demo?
Yeah. Very quick. Okay, perfect. So we have the server on the left and two clients on the right. We can see the first notification. If we put the wrong password, the connection is closed instantly. Okay, I will just keep. Okay, so just to show you, we can two clients can to connect on one server. We can see here different SMTP steps with hello, odds, and after we'll see other SMTP steps. And well, so we didn't have so many times. So I just want to show you, yeah, the queuing. So when we write an email and we send it just on the hello world and we finish by a point, it's going to the queue at the point JSON and it will be sent just after by the server, and here's the mailbox, or we can find all the mails that was sent just before.
Okay, that's it. Thank you. So before you go, I think you should make sure all your members come to the classroom. If no, maybe some of you to indicate who no show. And of course, maybe if some of you not no show at this, no presentation at this, you should let me know no presentation as well. So that we have one factor, the role of the maybe attending the presentation is important or not. So you should let me know that one. So some of you can let me know the status, because I cannot identify all of you. Maybe for some groups, all of you can have the presentation. For example, for the final one, group one missing. So Xu. Where is Xu? One Taiwanese in. Oh, drop it? Okay, that's fine, no problem. So you should let me know all the details so that I know how to have further evaluation for individual one if necessary. And try to let me know possibly the details. Of course, finally I will grade the final report. Oh, okay, maybe some of you let me have for the final report. I will grade the final report for the whole. For the whole group. All right. Of course, same. Let me know the contributions of each member. So you can modify if necessary. And so that if necessary, I will already have the different points. All right, that's all. So this is the final oral presentation. As for the final report, I will grade it soon. So this is the final activity, our final oral presentation. All right. As for the final report, actually, you should hand in today. I set it to the midnight of today. All right. And that's all. Any questions? If no, that's all. That's the whole semester. And possibly see you in the next semester. Okay, that's it. See you. Bye-bye.
Sorry, Professor, we can't prepare every necessary thing to the presentation. So I want to ask if we can show the demo video.
Sure, I will check it later. So you can upload to the Padlet.
Yes.